So good afternoon, students, and welcome to the Q&I summer course. So students, first of all, let me introduce myself. So students, I am Sunit Kumar, your mathematics tutor. And today we are going to continue with what we started in the previous lecture. So we started with the chapter polynomials, and today we'll do the second class for this polynomial chapter. Okay. So in the last class, what we had understood is, the graphical meaning, graphical representation of, the roots of a polynomial. Okay. So let's proceed with the class, students. So as I said, we'll start with this chapter polynomials. So today is the second lecture for this. The prerequisites for this class is that you should know about algebraic expressions. You should know what degree of polynomial is. What are different types of polynomials which we did in the previous class, that we learned on what is, constant polynomial, linear polynomial, quadratic polynomial, cubic polynomial, and biquadratic polynomial. Apart from that, how to find the value of a polynomial at a value of the polynomial at some value of the variable. For example, at x is equal to 2, how to find the value of a polynomial. This is what we did in the previous class as well. Apart from that, you should also know what is the meaning of zero of a polynomial. So that value of the polynomial, that value of the variable, which gives the value of the polynomial equal to zero, is called the zero of a polynomial. So this we had discussed in the previous class. Now, outline for today's class. Today what we are going to cover is, we will continue with geometrical meaning of the zeros of a polynomial. We'll do some examples and questions based on this. And then we will uh, we will learn today to find a relationship between zeros and coefficients of a polynomial, and also do some questions based on relationship between zeros and coefficient of a polynomial. So uh, quickly let us recap what we did in the previous class. So number of zeros of a polynomial of degree n. So in general, given a polynomial px of degree n, the graph of y is equal to px intersects the x-axis at most n points. So the graph will intersect the x-axis at most n number of times, where n is the degree of the polynomial. Therefore, a polynomial px of degree n has at most n zeros, right? Polynomial of px of degree n has at most n zeros. Number of zeros is n. Is this clear? So it can have any number of zeros starting from n. So maximum is n. You can have n minus 1, n minus 2, n number of zeros. Okay. Okay. Now here, look at the graph in figure given below. Each is each is the graph of one of the polynomial y is equal to px, where px is a polynomial. For each of the graph, find the number of zeros of the polynomial. So I'll ask you one by one where you have to answer me. So here, when you look at the graph, you see this is the graph, right? So the geometrical representation, what we saw is that the graph, when it cuts the x-axis at a point, we say that that is the zero. So how many times is it cutting the x-axis in the first case?
The first one time. One time.
One time. Ragul and Ragvi, correct. So number of zeros here is 1. Okay. Now in the second case, the graph cuts the x-axis 2 times. So what will be the number of zeros here?
2.
2 zeros, right? So number of zeros here is 2. So the number of times the graph cuts the x-axis will give you the number of zeros. So in the third case, you can see here the graph is cutting the x-axis 3 times at this point, and this point. So number of zeros here would be 3. Very good. Now in this case, fourth case, you can see the graph is cutting the x-axis at only 1 point. So what is the number of zero here? It is 1. Okay, good. Now in this case, though there is a parabola, but it cuts the x-axis or touches the x-axis at only one point. So here the number of zeros in this case would be 1. Very good. Now in sixth case, if you see, this is the graph. Now it cuts the x-axis at 1, 2, 3, and 4 places. So what is the number of zeros here? 4. Very good. Okay. So that means, let us conclude what we learned here is that if you draw the graph of a polynomial, if the graph of the polynomial cuts the x-axis at n number of time, the number of zero will be n. So if it cuts the graph at one point, it is 1 0. If it cuts it at 2 points, then we will have 2 zeros. If 3, then 3 zeros, and so on. Clear? Is the concept clear to everyone? Okay. Now in this one by one, you have to tell the first question. Here, this is the graph. Now you see that it does not cut the x-axis at all. What is the number of zeros here? No zeros. Very good. There are no zeros in this, in the first one. Second one, this is the graph. It cuts the x-axis at one point. What is the number of zero here? 1. Very good. In the third case, this is the graph and it cuts the x-axis at 3 place, 1, 2, and 3. What are the number of zeros here? 3 zeros. Very good. In this case, it cuts the x-axis at 2 places. Number of zeros would be 2. Very good. Now in the fifth part, this is the graph. It cuts the x-axis at 1, 2, 3, and 4 places. Number of zeros would be 4. In the next one, if you see, so here it touches the x-axis and here it cuts the x-axis. So there are 3 places where it touches or cuts the x-axis. So x-axis, so number of zeros is 3. Is this clear? Okay. Okay. Let's move ahead now. So now we'll talk about relationship between zeros and coefficient of a linear polynomial. Okay. So linear polynomial Px is given by ax plus b, right? This is the general form of a linear polynomial. Any linear polynomial will be represented by ax plus b, where x is a variable and a and b are constant. So if it is a linear polynomial, it will have only one zero alpha, right? If it is a linear polynomial, maximum number of zeros possible is 1, because the straight line can cut the x-axis at only one place. So actually the degree decides the number of zeros. So here, because the degree is 1, so the number of zeros will be 1. So in this polynomial Px is equal to ax plus b, if you have to find the zero here, so let's say alpha is the zero here. So the polynomial Px is given as ax plus b. So if x is equal to alpha is the zero of the polynomial, then p of alpha will be 0. Or instead of x, you will put alpha, a alpha plus b is 0. So this will give you a alpha is minus b, or alpha is equal to minus b over a. So this is your 0 of the polynomial, minus b by a. Now what is b? B is the constant term. And what is a? A is the coefficient of x. So when I say alpha is equal to minus b by a is the 0 of the polynomial, that means this is negative of the constant term by coefficient of x. Is this clear to everyone? How to find the 0 of a linear polynomial? Okay. So if you want to write this, please write this down so that I can move to the next slide. So relationship between 0 and coefficient of a linear polynomial. Here the relationship is that the root or 0 of the polynomial alpha is equal to minus of b by a, where b is the constant term and a is the coefficient of x. Done? Okay, good. Now relationship between zeros and coefficient of a quadratic polynomial. So let's say you have a quadratic polynomial px is equal to ax square plus bx plus c. This is the quadratic polynomial. Okay. Now, if alpha and beta are the zeros of this polynomial, quadratic polynomial, then you know that x minus alpha and x minus beta are the factor of the polynomial. Right? This we had studied in class 9th, that if alpha and beta are zeros, then x minus alpha and x minus beta are factors. That is what factor theorem says, right? So if alpha and beta are zeros, then x minus alpha and x minus beta are factors of this polynomial. Is this clear? So therefore, this ax square plus bx plus c, this can be written as k times x minus alpha into x minus beta, where k is a constant. So I have divided, I have split this quadratic polynomial into two factors, x minus alpha into x minus beta. Clear? Now, if I open this x minus alpha into x minus beta, what this is going to give me is x square minus alpha plus beta x plus of alpha beta. Now let us compare the coefficients. So when you take k inside, we'll have kx square minus k times alpha plus beta x plus k times alpha beta. Now comparing the coefficients of x square, x and constant term. So here this is ax square plus bx plus c. If you compare this, you will get this coefficient of x square is a here and it is k here. So we write a is equal to k. Here it is b and here it is minus k times alpha plus beta. And here it is c and this is k times alpha beta. So c is k times alpha beta. Right? So a is equal to k, b is minus k times alpha plus beta, and c is equal to k times alpha into beta. Is this clear, students? Now, you want to note this down, please note this down. This is important. How we are deriving the sum of zeros equal to minus b by a and product of zeros equal to c by a is what we are going to do right now. Has everyone noted this down? Okay. Now, sum of zeros is alpha plus beta. So alpha plus beta can be written as minus b by a, that is negative of coefficient of x by coefficient of x square. So we have quadratic polynomial as ax square plus bx plus c. So coefficient of x is b and coefficient of x square is a. So that's why minus b by a. Similarly, the product of zeros is alpha into beta, which is c by a, that is constant term divided by coefficient of x square. Clear? So this is important. Please note this down. This is an important formula. Sum of zeros alpha plus beta is minus b by a. Product of zeros alpha into beta is equal to c by a. This is for a quadratic polynomial px equal to ax square plus bx plus c. So the quadratic polynomial may have two zeros. The sum of zeros is minus b by a and the product of the zeros is c by a. Clear? Now find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between zeros and coefficient. So we have to find the zeros. To find the zeros, we will first factorize it by splitting the middle term. So we have x square plus 7x plus 10. If we split the middle term, we know that we can split it as 2x and 5x. The sum is 7x and the product is 10, 2 into 5. So we can write this as x square plus 2x plus 5x plus of 10. We can take x as common, you will have x plus 2. Here you can take 5 as common, you will have x plus 2. So this can be factorized as x plus 5 into x plus 2. Okay. Now, if we have to find the zeros of this polynomial, we'll equate it to 0 to get the value of x. So when you equate it to 0, when the product of two things are 0, means either of them can be 0. So x plus 5 is equal to 0 or x plus 2 is 0. So you will have x is equal to minus 5 or x is equal to minus 2. So we have two zeros, alpha will be minus 5 and beta is minus 2. Now alpha and beta can be interchanged as well. Here we have said, we are saying that alpha is minus 5 and beta is minus 2. You can also say alpha equal to minus 2 and beta equal to minus 5. The naming can be interchanged. Clear? So once you have got the zeros, what has been asked here? Verify the relationship between zeros and coefficient. What were the relationships? We saw just now that sum of zeros alpha plus beta is minus b by a, and the product of zeros alpha into beta is c by a. Right? These were the two relationships. Now let us first verify the first one. So we know that LHS here is alpha plus beta, which is minus 5 plus of minus 2, which is minus 7. And the RHS here is minus b by a. So if you equate the coefficients here, so you will find that because the general form of polynomial is ax square plus bx plus c, so that means the value of a is 1 because the coefficient of x square is 1. Value of b is 7 because coefficient of x is 7. And value of c is 10 because c is the constant term. So a is equal to 1, b is equal to 7 and c is equal to 10. Put the values here. So minus b by a means negative of 7 by 1, which is negative of 7. So both of this LHS and RHS are equal, right? So that's why this is verified. Yes, Raghavi, you are correct. Now here in the second case, that is alpha beta is equal to c by a. So we know that the LHS is alpha into beta. Product of the zeros will be minus 5 into minus 2, that is plus 10. And the RHS is given as c by a. So the constant term c is 10 and coefficient of x square is 1. So this will be equal to 10. So here also you can see that since LHS is equal to RHS, we can say that this is verified. So here we have verified both the relations of sum of zeros equal to minus b by a and product of zeros being equal to c by a. Is this concept clear to everyone? And the steps clear? So first what we are going to do is you will first factorize it into two factors, equate them to 0 and get the two zeros. Once you have got the two zeros, then you will verify whether the sum of the zeros is equal to minus b by a or not. Again, you will verify whether the product of zeros is equal to c by a or not. Once it is verified, you will write that both of this is verified, and hence your question is complete after that. Is this clear to everyone? Are the steps clear? You can give me a thumbs up if it is clear to everyone, or you can write it in the chat. Okay, Devi Maya. Raghul, Ragvi, Jovin and Ellen, is it clear to you? Okay, Jovin. Okay, great. So let's go ahead, students. Let's do the second one. You have to find the zeros of the polynomial x square minus 3 and verify the relationship between zeros and the coefficient. So first of all, please tell me the two zeros first. What are the zeros of x square minus 3? Yes, Raghavi, correct. Zeros of this polynomial are root 3 and minus root 3. So how do you get it is, equate it to 0 and solve it. X square minus 3 is equal to 0. So you can write x square is equal to plus 3 or x is equal to plus minus root 3 when you take a square root on both the side. So both the zeros, one of the zero alpha will be root 3 and the other zero beta is minus of root 3. So this is how you get both the zeros alpha and beta. Once you have got the zeros, now we have to verify the relationship between zeros and coefficient. How do you do that? Is the sum of 0 alpha plus beta is equal to root 3 plus of minus root 3, which is equal to 0. And the product of the zeros alpha into beta will be equal to, so before that you will have to calculate minus b by a here because you are going to verify this first. So we can see since x square minus 3 is the polynomial, the value of a will be 1, the coefficient of x square. Value of b is 0 because there is no term of x. That means the coefficient of x is 0 and the value of c is minus 3. So we can write this as equation as 1 into x square plus 0 into x minus or plus of minus 3. So this is ax square plus bx. If you compare it with the general form, ax square plus bx plus c, the value of a is coming to be 1, value of b is coming to be 0 and value of c is coming to be minus 3. Is this clear? So alpha plus beta is minus b by a. So alpha plus beta is 0 and what is minus b by a? This is negative of 0 by 1, which is 0. 0 divided by anything is 0. Now similarly, so this is verified, both LHS and RHS are equal. And again alpha beta is equal to product root 3 into minus of root 3 is going to give you minus 3 and c by a is going to give you minus 3 by 1 which is equal to minus 3. So alpha beta is equal to c by a. This is also verified because both alpha beta and c by a are equal. So we say that this is verified. Is this clear to everyone, students? Have you understood this question also? Okay. Shall we proceed now? Shall we go to the next? Okay. Now to find a quadratic polynomial whose sum and product of the zeros are given. So what we did till now was there was a relationship which we established between the sum of the zeros and the coefficient of the quadratic polynomial. So what we had learned that alpha plus beta is minus b by a and alpha beta is equal to c by a, right? These are the two things which we saw. The relationship between sum of zeros and the coefficient of uh, x square and x. Similarly, relationship between product of zeros and relation and constant term and the coefficient of x square. So these are the two relations which we saw. Now in this part, what we are going to do, we are going to find a quadratic polynomial whose sum and product of a zeros are given. Means alpha plus beta is already known and alpha beta is already known. Now we have to find the complete polynomial, how the polynomial would be looking like. So here it is just the opposite of what we have been doing. We had a polynomial, we found alpha beta. Now if we know sum and product of zeros, we have to find the polynomial. Okay. So if alpha and beta are the zeros of a quadratic polynomial px, then the polynomial px is given as k times x square minus alpha plus beta x plus alpha beta. This is the polynomial. So we already know alpha plus beta. The sum of zeros is known and we also know the product of zeros, then our polynomial will be of the form k times bracket x square minus alpha plus beta x plus of alpha beta. Okay, so if alpha plus beta is known, we'll put the value here. And similarly, if alpha beta is known, we'll put the values here and we'll get the polynomial. The value, the k is a constant whose value can change from anything 1, 2, 3, and so on. It can have any values. K is a real number, right? In general, when we have to find a quadratic polynomial, we choose k so that the coefficient is not a fraction. So in general, we take k as 1, and if we have alpha plus beta and alpha beta as fraction, then we choose k so that the denominator of alpha plus beta and alpha beta gets cancelled. We'll look at it one by one when we do the questions here. So quickly note this down. Note this down. If alpha and beta are the zeros of a quadratic polynomial px, then the polynomial px is given by px is k times x square minus alpha plus beta x plus alpha beta. Or you can also say that it is equal to k times x square minus sum of the zeros into x. What is alpha plus beta? It is sum of the zeros. And what is alpha beta? This is product of the zeros. Clear? Is this point clear to everyone, and has everyone noted this down? Have you noted this down? Good. And what about others? Alan? Okay, great. Let's go ahead. So find a quadratic polynomial, the sum and product of whose zeros are -3 and 2 respectively. So what is given is sum of zeros alpha plus beta is -3 and product alpha beta is equal to 2. This is given in the question. Now, what will be the quadratic polynomial? What will the quadratic polynomial look like? So Px is equal to k times x square minus sum of the zeros alpha plus beta x plus product of the zeros alpha beta. So this will be k times x square minus what is alpha plus beta? This is minus 3x plus of alpha beta, that is 2. So we will write k times x square plus 3x plus 2. Clear? Yes, it is correct. Raghavi, it is correct. So now here we know that we can take k as any real number. So if we choose k is equal to 1, then in that case, the polynomial px is x square plus 3x plus 2. Now the k can be chosen any number. K can be 2, k can be 3, and you can have different polynomials with the same sum of the zeros and product of the zeros. It depends on the value of k. So one of the polynomial is x square plus 3x plus 2 where k is equal to 1. Is this clear to everyone? Have you all understood this concept? Please note this down. Now I'll do one more example, right?
Sir, I have a doubt.
Yeah, Jovin, please tell.
So K can be any number, whatever we want, or do we have to like actually find it?
No, k can be any number, any real number, you can put it as coefficient. Now, in general, what we do, because we have to write only one, the question says find a quadratic polynomial. So you have to find only one quadratic polynomial whose sum is -3 and product is 2. So in that case, we take the value of k as 1 because it makes the calculation easier, and that's the most simple form. And that's why we take k as 1. I'll do one more example where we don't take k as 1. I'll do it just now.
Okay, sir.
Okay. Okay. So here students, now in this, for example, if the sum of the zeros alpha plus beta is given as minus 1 by 6, and let's say the product alpha beta is equal to, for example, 2 by 3, right? This is given in the question. Now you have to find the quadratic polynomial. So if you have to find the quadratic polynomial px, we will write this as k times, x square minus sum of the zeros alpha plus beta x plus of alpha beta, right? So this is k times, what is x square? Minus alpha plus beta is minus 1 by 6. So we'll put it here minus 1 by 6x plus of 2 by 3. So this is k times x square plus x by 6 plus 2 by 3. Now, can you tell me what we should take the value of k as, so that the coefficient of each of these x square, x and the constant term, these are integers? What should be the value of k so that coefficient of x square, x and the constant term all are integers? Please let me know. What should you take the value of k? So if you see this, the coefficient of x is 1 by 6. So in denominator, you can see 6 here, and here you can see 3. If I take the value of k as the LCM of, yes, correct. Ragul, it is correct. So if you take the LCM here of 6 and 3, so LCM of 6 and 3 is 6. So what you are going to take the value of k as, take the value of k as LCM of 6 and 3. So LCM of 6 and 3 is 6. So you will take the value, the polynomial px will become 6 times x square plus x by 6 plus 2 by 3, right? So which is equal to, this is 6x square, 6 into 6, 6 into 1 by 6, this will get cancelled, so plus x, and then you have 4. So 6x square plus x plus 4 is the polynomial. Is it clear? Is it clear, students? You can note this down. So the value of k depends on what are the coefficients of x square and x. If the coefficient of x square and x, these are whole numbers only, then value of k will be equal to 1. We'll take value of k as 1. Now, if coefficient of x square, x and the constant term, these are not whole numbers or integers, what we are going to do is we'll see the denominators, take the LCM of the denominators if we have different denominators, and then take the value of k as the LCM of these denominators. Clear? Okay, good. Has everyone noted this down? Okay. So this cubic polynomial, we don't have to do a proof of this, but yeah. So for board examination perspective, this is not very important, because in board exam they don't ask you questions related to cubic polynomial. But yeah, for your for your foundation to be strong for competitive exams, you should know this concept as well. So relationship between zeros and coefficient of a cubic polynomial. So because it is a cubic polynomial, there are going to be 3 zeros here maximum. So let's say these 3 zeros are alpha, beta, and gamma, right? So if alpha, beta, and gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then in that case, the relationship, the sum of the zeros is given as alpha plus beta plus gamma, that is minus b by a, that is negative of coefficient of x square by coefficient of x cube, alpha beta plus beta gamma plus gamma alpha. This is equal to C by A, that is coefficient of x by coefficient of x cube. Similarly, alpha beta into gamma is equal to minus d by a, that is negative of constant term by coefficient of x cube. So it is easier to remember this because the denominator is in each case a only and the numerator starts from b. So first when you start, you will start from a negative number, so that is negative b by a. Then you have alternate signs, go alternate. So if it is negative b by a, then you will have c by a in the second term, and then you will again have minus d by a in the third term. Is the pattern clear to everyone? Have you understood the pattern here? So the denominator always remains a, and the coefficient and the numerator is going to be starting from b with a negative sign. Then you will have c with a positive sign, and then you have negative sign with d. Now, if you have understood this pattern, let's say I write a polynomial of degree 4, that is ax4 plus bx cube plus cx square plus dx plus e. Right? Now, in this, if I have to write the sum of this alpha plus beta plus gamma plus delta, for example, there are 4 zeros. Now, what would be the sum of the 4 zeros? Can someone guess? Pattern is going to be same. We will start with negative of b and the denominator as a. So the sum of the zeros is minus of b over a. Okay. Now taking two products at a time means alpha beta plus beta gamma plus gamma delta plus delta alpha. This is going to be, what will this be equal to? C by a, Raghavi. Very good. So this is C by a. Now, the sign is positive and we go to C, the second term. We started with B. Now, if we have to take three terms as, as pair, alpha beta gamma plus beta gamma alpha plus gamma alpha beta. Right. So alpha beta gamma plus beta gamma delta plus of, we have delta alpha beta. Right. These are the three. Alpha beta gamma plus beta gamma delta plus delta alpha beta. What is this equal to? So this is C, and after C, what you are going to get? D. So we will have minus of D by A. And then last you have alpha, beta, gamma, delta, means product of all four. So product of all four is going to be E over A. The signs will be first negative, then positive, then third again negative, fourth again positive. And we will keep on going from B to C, then C to D, and then D to E. Is this clear? So Raghavi and Ragul, when you take product of 3 at a time, then it is minus D by A, and when you take product of all 4, then it is E by A. Is this clear now?
Sir, the denominator will always be a.
Denominator is always going to be A.
Okay, sir.
Okay. Now, students, I'll quickly take you to the platform and will give you the homework for today. How many of you attempted the homework which I gave yesterday? So I had asked you to do a chapter practice for the whole chapter, real number. How many of you did that? Raghavi, Ragul, Devi Maya. So students who have not, who have problem in, logging in on the platform, or you are facing any problem, please join the practice session which we have at 6 p.m. every day. So whatever issues are there, we'll resolve the issues then and there when you are there in the practice session. So please join today at 6 p.m. everyone, and we will see what problems are there. We will have our team together and we'll resolve all the issues so that you all can join and start practicing during the class. Okay? Okay, Devi Maya has done it. What about Alan, Jovin? Could you attempt the homework which I gave you from the platform?
Sir, yesterday we didn't receive an email that there was class.
Yeah, we had a class and everyone was sent a email. I'll
I didn't
just check
receive
it
one
for you.
yesterday, sir.
I'll just check it, Jovin. What's the issue? But yeah, we had sent it and we had a class yesterday. So you could not attend the class yesterday, is it?
Yesterday I did not know there was class.
Okay. So the classes are every day from Monday to Thursday, same time, and the link is also same for the class.
Okay, sir, yeah.
Okay. So I'll quickly take you to the platform. So, students, when you log in, you will see this dashboard. You will have to go to assessment, practice and custom practice. So here you can see the topics, right? So we have done polynomials today. So we'll start the platform practice for polynomials from today. So today you have to do this, explain the concept of degree. So this we had already covered in the previous class. Okay, so today you will practice questions from explain the concept of degree. Is it clear, students? Is the homework clear to everyone? Explain the concept of degree. So today when you come in the evening at 6 p.m. for the practice session, we will do questions from this particular topic. Okay? So let us all meet in the evening session of practice from 6 p.m. to 7 p.m. So please join that session so that we are able to help you with your login if you are not able to log in. And if you are able to log in, then you can straight away start practicing the question when you join for that practice session. So thank you, students. Thanks for joining in. And we'll again meet in the evening at 6 p.m. for the practice session. And also we'll have the class tomorrow at the same time. So please join in there.